Paul here, and on the bench today we have another Westinghouse MobileAire fan motor. I just did one of these. Unfortunately, the one I just did, the stator was totally fried. This one I entitled Fire in the Hole because the owner said that some flames flew out of the back of it and it quit working. This must be part of the line input here. I don't see the other wire. See it somewhere. No, it must be taped in there with the resistor. Okay, let's check it out. I made it easy. Sort of easy. Okay, we got that off. Little piece there. Sticky, gooey. Okay, the one that I recently uploaded that had the bad stator had a blown resistor. It was totally open, and the capacitor was actually tested good in that one. Amazingly. Oh, there's the other wire. Okay. Oh, wow. Yeah, the insulation's come off it. Hopefully the fire blew out of here and not out of the motor, but I believe he said it blew out of the motor. First thing we're going to check is this resistor and see if we have any continuity on it. Should be around 28 ohms. I may not be able to check it until I open the case. Okay, we'll come back to it. Usually there's enough bare wire you can get probes in there, but not on that one. Let's disassemble and we'll get started. The utility. Alright, grab a container for the pieces. Need a convincing device. Alright. Me, go on. Alright, let's see. Well, that ain't gonna fit through there, is it? Let's get the worst of the wires out of here. Alright, there's a little nut that goes, washer nut goes together there, so we'll just stick them on here where they go. Alright. There's Mr. Cap. Alright. And there's that wire. And this wire. And of course this one is the switch, which in this case will be the neutral, because if we do get it going, we'll be putting a new line cord on it, and actually no, this one won't get a new line cord, so it won't matter. Well, you can see we got the normal problems with the motor wires here. This is the yellow, green, and red wire for the motor. These two go to the resistor, so here's where we can check the resistance, and we can pull it right off this, and off the switch. No, we can't get it off the switch, but we can pull it off this capacitor, so that's wired into the same green line where this one here, that's this one on the capacitor, the other one goes in here, so we'll just take this off temporarily to check that. Okay, I'll put some alligator clips on my probes. I need to buy me a set of good probes that have alligator clips already on them, or I need to make a set, because I use alligator clips so much more than I use the actual probes. I use the probes probing around inside of a chassis, but for electrical work, alligator clips. Okay, so there's one half. And the other one we said was this side of the capacitor. Let's put this on ohms. Give it a second to adjust. And we should have around 28, or so 26.8. Great, resistor's good. Capacitor, you can't really check it in circuit, but I mean, you can get a ballpark. Let me go ahead and put that cap back on there temporarily, because that cap is to the switch, and we're not going to be dealing with the switch much at this point, other than make sure it works. But let's disconnect this. The capacitor goes across one of the coils in the motor. Oh, that one don't want to come off. Yeah, it took the tip right off, but I'll put new caps, new ones on there anyway. Okay, now we can check the capacitor. The yellow one's the power. These two are the power that here coming in. All right, let's check capacitance. Right there. And see if we at least get a ballpark 3.3 microfarads on this capacitor. It's going to be changed anyway. 4 3.9. It's charging up a little. Okay, so 4 microfarads roughly on a 3.3, which means it's out of tolerance, but worse than that, it leaks AC, so it's not good. Secondly, and also a benefit of changing them is we will not use the 3.3, we'll put a 2.5. This was built back when line voltages were 110, some of them were 112 to 115. Shortly thereafter, they went up to 117. Now we're up to 120 to 125, 126. So by putting a lower capacitor, run capacitor, this is a run capacitor, by putting a lower run capacitor, we actually drop the voltage down a little bit, which keeps the motor running cooler because it'll be running back in the voltage that it's optimized for and was engineered for rather than today's voltages. Additionally, this is a 330 volt AC oil capacitor. I have another one here from another unit that I've replaced already. So, I mean, I do a lot of these MobileAire fans. Sorry about that. And I had one around here somewhere. Oh, here it is. This is why I don't like these oil-based run capacitors. They explode. They don't just go bad. I mean, they go bad, but nobody knows they've gone bad. They sit there bad, frying, getting hot, and then whammo, they blow up. This was a 4 microfarad, 370 volt one that blew up, and this was on an air handler motor. Same kind of motor, right? Single phase motor. So you see how it all swelled up out of shape and then exploded. It spewed electrolyte all over the place. So I don't use those. I replace them with a modern, much more quality made solid state capacitor. And this is a 2.5 microfarad instead of 330 volts AC, which, by the way, plugging this into 120 or 122 or 125, you're up close to the 330 high end of this capacitor, which again makes them dangerous, right? This drops the voltage down, so you're nowhere near the 330 volts, and it's a 450 volt rated capacitor. And it'll run in both 50 and 60 hertz, so it's made for Europe and America. Look at the difference in size, and does a better job than this oil-based, possibly exploding capacitor. But we just checked it, and it's 4 point something microfarads, so, you know, it's pretty well up there from 3. Let's see where we're at. 3.3 plus 20%, give or take. This is good for up to roughly 3.9 microfarads, and when we checked it, it was 4 and some change. So it was already out of its 20% sides. Look at the dent in there where they banged it into the can. But it still seems okay physically, but electrically, well, one, it's heavy, and this is so light. It's got a lot of oil in it, right? It's just a heavy device. So getting rid of that is a good thing. Okay, what we want to do, and that's probably going to break off. That wire's probably going to break off. We'll just jumper this one in right here and to the new wires. Actually, let me go ahead and, where did that go? They went to this red wire. Let me get a cap. We'll recap that with a, this wire's in bad shape. I gotta check this. This is the motor coil, stator coil wire, so let me check it, but that's where it goes. So I'm just gonna stick that on there for a second. Because this one is shot. The wire broke off inside, it wouldn't let go. That's trash. Alright, so we got the yellow, we got the red, and the other motor wire is this green, which also goes to the switch. So we'll just take the cap off and hope those wires stay together. You know what I'm going to do? For right now, I'm just gonna tape those wires together with some nasty cellophane tape that never likes to peel off, but that's why I'm using it. It'll keep those wires intact. When we want to separate them, we can separate them, but for right now, I'm just gonna keep them together. Okay, makes it easy. I don't have to diagram it out, but I already know how it goes pretty much. Okay, so the green wire goes there, the red wire's here, the yellow wire's here. We need to ohm those out, and hopefully we'll hope that they're good. So we'll call the red, we got red, so we'll go red to green, red to yellow, and yellow to green. Okay, and that's the 3 coils in the stator. So get back on ohms. Can you see the meter? Oh yeah. Okay. And let's start with, we'll keep the red on the red for the first couple measurements. So red to green. Oh. That's the exact problem I had with the last one of these. The red wire was fried. That's the main coil in the stator. Here, well, we still got continuity to yellow, but we don't have none to green, and that's even worse. We got 86 ohms. 86.8 ohms. That's worse. The reading's really good. The advantage would have been that it didn't work here and it didn't work there, and the red wire was just broken, needed to be reconnected. But the fact that it's working here means the red wire is not broke. Now, it's possible the green wire is broken there, in which case we can just connect it together. We're going to do a test right now between yellow and green. If we get any reading at all, then the stator has a broken wire in the stator, and it's not one of the wires connecting to the stator. So we will see. Here's our test, and it's open mode. So there is a chance that this green wire has just broken free and we can connect it. There's a chance. That's what we have to hope for. There's also a chance that the green wire is just broken here, right? But I don't think so. I think it's further in the motor. So what I'm going to do is just say or document audibly through this video what we got going on here. And so what we have, okay, what we have is the one side of the resistor is going to the capacitor, going to the red wire, going to the switch, and it's going to the green wire, going to the motor. And I think I will draw it out. It's just much better. So we'll start with that one again. We got a resistor. From the resistor, we're connected to the green wire. Okay, so we'll draw the motor here. We have a green wire. It's going to here, and we'll call this one G for green. Keep our thing going there. We have a red wire, which we'll put here, and we have a yellow wire, which we'll put here. And the way they connect together is that in the motor, there's an auxiliary coil that goes there, and then there's a main coil that comes here and connects in the middle. Okay, so coming from there, we go to the green wire. We also go to the capacitor, so I'm just going to draw the capacitor right here. Okay, and that's just that side of the capacitor. They're connected to the green. So, and we're going to probably, since that's going to right to the motor, that's probably high on the switch. So we will draw the AC switch here, the AC plug, and we'll have a wire coming out, comes down to a 0, or off position, and then there's a 1 and a 2 position, 2 being high. So most likely, this green comes around and connects to high. Okay, now, the red wire, which we stripped, connected to the other side of the capacitor, so it came across here and connected to there. So the capacitor is in parallel across this coil, or this connection to the motor stator. The other side of the resistor comes out and goes to number 1, which makes sense, right? Because it adds resistance in the line. It connects to number 1. So high, or straight in, and the yellow wire goes to right to the other side of the plug. So I probably should have drew that wire over there. I'm just going to come out this way. This one goes right to the motor, connects to the yellow wire. Okay, so the power goes directly to this side of the motor. The other side comes, when it's on high, skipping all of this stuff, it comes right to the green side of the motor. So the AC is right across this, and there's a capacitor across this coil. Okay, when you go to 1, the capacitor is still across this coil. The AC is still going into, can you see that? I'm talking to myself. Oh, I am sorry. Let's try that again. Okay, one side of the AC goes directly to the Y side, or the yellow wire of the stator coil in the fan. The 0 is off on the switch. This is the switch. Okay. When you put it on high, you're bypassing the low and you're going to high speed. It's direct. The other side of the AC is directly connected to the green side. So the AC is across the Y and the G. And this capacitor is across these two. It's in parallel with these two. Now when you put it on 1, instead of going directly to the G, to the motor, it goes through this resistor, which is this resistor here, and this 6.8 ohms, whatever, goes through there directly to the motor. So it's got a resistor that drops the voltage down, and that's what slows the fan down. When it's on high, it's directly connected to 110 volts or 120 volts, depending on what you put in it, is going right across this coil of the motor, and this coil is getting power from this line through this capacitor that's across it and energizing this section. When you go to 1, the AC line goes through this resistor, which drops the voltage. So if you had, say, 120 volts, when you come through 1, you're probably dropping 15, 20 volts here, and the rest of the voltage, so 120 here, you got 100 across it, because 20 volts is dropped there. Okay, let's just give you an idea. That's not the right numbers. So anyway, that's where we're at. Now the capacitor does something else too. It increases the voltage. That's why across this coil assembly. That's why I say when the voltage is high, you want to drop this capacitor value down, because the higher the capacitor value, the higher the voltage this motor is running in, and the more heat generated in the motor, which we will see when we open this up. I'm sure that it'll be flaky and falling apart. Now what we have is a break somewhere in this green wire. Somewhere in this green wire we have a break. And it's broken somewhere between here and here, which means the break is in here. Okay? Between here and here we're okay, but between here and here we don't have any connection in here. We have connection this way, but we have none this way. Now, of course, it isn't going to get through the capacitor, because this is DC, and DC sees that as those wires don't touch, right? So it can't get through here to get over to there. It can't get through here to get over to there because it's unplugged. There's not even a line cord on it. So it can't go through the circuit panel and come back. So by having it unplugged or disconnected or the line cord gone, that's the same as unplugged, it can't go through the resistor, it can't go through the capacitor, it has to go through this coil to get to the other side. It's not doing that. So what we got to hope, since it is going from here to here, and we are not getting anything from here to here, we got to hope that this green wire is broken somewhere here, and not in the coil in here. If it's broken in there, that is bad, because we can't fix it, and the motor's no good at all. It would have to be rewound. There's only one guy I know that does them. It costs $250 to rewind the stator, plus shipping. The motor is not worth it. You can buy a fan that works, the same fan that works, for around $200. Used, of course, not reconditioned like we're going to be doing if we get it working. But I just want you to be aware that if we don't get this green wire connected to this coil in here, and it's broken somewhere in there, we're already out of luck. The last one I did was broken in the coil on the red wire. This one's broken probably in the coil on the green wire, but let's hope not. Let's hope it just burnt and popped off right there, and we can reattach it. To find out, I got to take the stator out of the case. I got to take the motor completely apart. So I'm not even going to worry about this circuit other than marking where things go. We know that and we already did, the red goes to the line, to the capacitor. Right? Yeah, the red went to the capacitor, they were connected together. The yellow goes directly to the AC line, that's the one that was loose in the can when we opened it, and this is the other side that goes to the AC line, which is a switch. Okay. So we know where everything goes. Not worried if that capacitor line breaks off, it's a black wire, just like the other black wire, they're the same, so I know which one's the capacitor, and we know it connects to the green wire with the resistor. So we're safe on all that. So the first thing, before I can even do that, I want to get all of this off the motor. So I want to get this resistor out of line, and at least off this guy here. So let's do that. I'm going to shut this off and get it out of the way. Take this, put it there. And we'll take this off. I'm going to throw that in there for now. Put that in there, and there's our new connector. Actually, you know what? Yeah, I'm going to have to bang on this. I don't want to be banging on it and break this resistor. I got to get it out of the way. This stuff that's falling out is mica. It's like an insulator that they used to use back in mid-century modern days, and it deteriorates over time, so it just falls apart. Also crystallizes, and it'll eventually short out, and that's by a disease that happens to them. Well, it's not a disease, but they call it a disease. They call it silver mica disease. And so we got to be careful with it. There's not much we can do about that problem. But so far, it's working, and it's got the right resistance, so we're not going to worry about it. We're just going to connect it back where it goes, so we don't get damaged, and we're going to separate it. You can always put a power resistor in there if need be, but I'd rather not. This resistor works. We want to leave it in there because resistors last a long time. Unfortunately, the mica doesn't. So we already know that this green wire goes to the capacitor, to the resistor, so we can pull that one through. And we know that the other side of the capacitor goes to, the resistor, the other side of the resistor goes to the switch number 1, the low speed, which is right there. So we can pull that through. And that separates the resistor. Put him in the box. It also separates all of this. We get it out of the way, so we're in the box. The tape came off, of course. And now we're up to this guy. I'm hoping this one didn't get as hot as the last one. Let me get a wrench. I'm also hoping I can get it out of the case easier than the last one. The last one overheated so bad that it welded the boat to the side of the case. New tool from China, I swear. Okay. And yeah, I cut myself. I know young people today would probably go home, take the rest of the day off work, especially on a Friday. Like today, oops, sorry. But I'm not a young person. Okay, let's see. Yep, it's tight. That's always nice. All right. What we want to do is make sure that we can get the motor housing off without hurting the. Oh, there we go. Got it. Oh, yay! Oh, well, that don't feel good, but oh, there we go. Yeah, that motor's in nice shape. That's in good shape. The coil is not as hot as most that oh boy, I spoke too soon. Take that off. See this one here? It's all black. I bet any money that that's the one that this green wire is broken off in. In fact, I'm pretty sure it is. I see damage. This is where the fire came from. The stator is no good. Alright, I just disconnected the camera so I can show you this. Let me get a light over here. Another customer I gotta give bad news to. Look it in there. Hold on, let's get this light better. Okay. Do you see? Let me get a pointer. Okay. This is where the fire in the hole was. You see those big knobby round things? That's melted copper. Melted copper, and that's where it busted free. And it melted so bad that it melted a bunch of copper around it, and it overheated this whole coil. Yeah, that's totally shot. That's toast. So all the insulation's burnt off. The wires are black except where the insulation fried right off. This insulation is fried off and shorted against each other and blew out the coil. And hold on a sec. Okay, you can probably see what's going on. I connected my meter to try to find continuity on this green wire, and this coil is totally toast. You see all the burnt wires on it? I've been trying to find one. They're all burnt right through. Even the string that went across. See, there's one of those bubbles of copper where it melted the copper. Been trying to find one that was still connected to this green wire, but apparently it's fried inside. Probably in the middle of this coil is where it broke off, and I can't get to it to touch it. But all of these are toast. All of these are burnt right through. This whole coil is black and burnt through, and that's where the fire in the hole was that blew out of this stator. It's really sad because the rotor in this is in really good shape. Most of the coil in here is in really good shape. Nice shiny copper with good lacquer. It's one of the best ones I've ever seen as far as the condition of the motor. It's really odd that it blew there. I don't know what caused that. Could be the voltage difference between mains today and mains back when this fan was made, right? Higher voltage today could have done that, and just somehow one of them got hot enough and burnt through the lacquer and burnt through the one next to it. Here's the wire where it jumps to the next coil right here. You see it? It goes up there to that coil. it got a little hot too, but it's not as bad. Right there. Sorry about that. I'm trying to balance the camera and use the pointer at the same time. But that's what connects this coil to this coil. So I don't know what made this particular coil here, this coil of the stator assembly. This is, the stator is one, we consider it a stator coil, right? One big coil. It's really not. It's a number of coils connected together. And those are the poles of the magnetic field. This is a 6-pole motor. And this one inside, this one that goes around, it looks like it goes this way. Those are still coils inside going the same way. It's just that they're bridged in a different area. They go from here to here rather than from here to here and here to here. They go across, they're in between. And that's the phase shift that makes the motor run. Well, these are, this is a finer wire than this wire. This is the red to green mostly. It's the main coil. It's a thicker gauge wire. Not a lot thicker, but it is a little thicker. This is a thin gauge wire. This is the auxiliary coil, the yellow to green wire. And they both connect together. They connect together at a certain point in the ring, you know. But what made this one blow, I don't know. But that's where the fire come out. You can see it toasted, everything in there. See all that soot from the toasted coil. Unfortunately, there's nothing can be done. It takes a factory pretty much and the right equipment to rewind these. It's not something that most people even try to think of doing. It's very, you got to have the right tools, right? It's not something we can do. Like I said, I only know one guy that does it. There are a couple, but I know of one that does it. It's highly recommended, and he's booked all of the time. But he gets $250 a stator plus shipping. And this fan isn't worth it because you can buy a used fan of this age, a MobileAire fan that is working. So for that, of course, it won't be restored like we were going to do with this one. But if it's a working fan, it's a working fan, right? And if you can get it cheaper than you can rewind a stator, then, you know, because rewinding the stator is not the full charge. That's just the charge of the stator. Then there's also the, you know, the redoing of the motor. It still needs to be reworked. You wouldn't pay to have a stator put in there, brand new stator, and take the risk of burning it up. You have to clean up everything else, right? The capacitor, oil, and service the motor, bushings, all that in there. Those bushings would have to be cleaned up and reworked, and new head wire put on it. I mean, this wire is getting old and brittle, and you see what it's doing. It's not going to last forever. It could short out and cause a problem. In fact, that could be what happened, but I don't think so at this point. It's just the cloth covering that came off on this one. I don't see no evidence that the insulation on the wire itself is broken. But eventually this will turn to steel. I mean, it'll just get hard and brittle and then break. And you can see that this wire here, these are these three wires. So you got a red, a yellow, and a green. That's these. And you can see that they did get hot, because look at the color. You see which one's the red, yellow, and green, right? Well, I can tell you, this is the red, this is the yellow, this is the green. But these two look almost black. And that one ain't far from it. Of course, now a lot of that is the covering that they spray over the wire, which burns off, you know, gets brittle, and you see it just falls off. That's normal. That happens. Normally when I redo these coils, I re-shellac, I spray, get all this off, I break it all off, and I spray shellac on it and recoat it. But, and it could be that that's what shorted this out. So much of that fell off, and then something got hot, you know, hot enough to break that wire. Anyway, I hate to give the owner bad news, but this stator is burnt, and there's nothing I can do with it. I hope you found this video interesting. Those of you who work on these, at least you know what to look for and how to detect these kind of issues. This is common on these MobileAire fans. They get a lot of use. They usually run in a factory where it's hot, and they're on all the time, and they're on high current and high voltage. and then these capacitors start leaking. I mean, this capacitor tests good, but testing good is not the only issue. They're supposed to, they got an internal resistance as well. We didn't check resistance on this one, but usually you have to check it at a high voltage. You can't check it with a digital voltmeter because you don't have enough voltage. If there's a voltage, if the resistance fails at a particular voltage, like say 110 volts AC, it breaks down. Well, that could burn out a coil, right? Let's see if we get anything on this. Should be nothing. Yeah, should be open load. But again, it's open load because this is only running a couple volts DC across here, so that don't mean anything. Oh, look at it is having issues. You see that? So it could be that this capacitor has gone bad and has literally burnt out this. Remember, it was open load. That's what it should be, but look at it. The resistance is dropping. We're down to 27 megs. That's not what's concerning me so much as how fast it's dropping. Now, if this was running for, say, 8 hours, I bet it was this capacitor that burnt out that part of the coil. Because, let's see, again, the capacitor is across the yellow and green. Yeah, see? Capacitor is right across that, right across the green and the yellow, and that's the green is the one that's burnt up. So this capacitor is what burnt this up. That's a warning to you people who have these mobile air fans. Just because they're running, if they have never been serviced, their age right now, you're pushing it. These capacitors are out of value for their capacitance value, but they're also the series resistance is really bad, and so they're putting, not only are they getting higher voltage than they're supposed to get, but they're putting that higher voltage right across that little tiny thin copper wire. And so if you work on these fans, change these caps. I don't care if they test good. Leave them in, you're leaving a disaster for the owner of the fan. Change the thing. It doesn't take time, and it's got to be done. They got to go. They're too old. These capacitors are old. So if you have a MobileAire fan and it's still working and you haven't had it serviced and it's got the original capacitor in it, this is going to happen to your motor. Sooner or later, this is going to happen to your motor. Get it serviced. Don't wait till there's fire in the hole. And it's no reflection on the current owner. Who would know, right? Who would know that this was going to happen? But it happens. And so I'm trying to educate people, not say anyone did anything wrong. Nobody's doing anything wrong. They just don't know. And in fact, that when I started working on these, I didn't know. And I do electronics work and electrical work, but I didn't know that that could do that. But it can. And that's why I change them. So if you've got a MobileAire fan, get that capacitor changed. If you don't do anything else, change that capacitor. You could even do it yourself. You could take that can out, open, and slide it out. If you can just at least remember where the wires are connected, pull this out of here. You could just cut these wires right off here, strip them, and put a new capacitor in there. Get a new one like this one, right? And just wire cap the wires together. You know what I mean? Put new wire caps on. You don't need to solder them. Just wire cap them. It's a regular electrical connection, so you don't need solder. Anyway, hopefully this was educational for you all that have these fans, and make you realize that you got to take care of these. They're rare, and time's running out on them, and there's fewer and fewer people like me who know how to even work on them. So keep them up to date as much as you can, because sooner or later you're going to be using plastic junk from China like everybody else. And you don't want to do that. This is an amazing device. These things are amazing. The fact that they've been around as many years as they have is just unbelievable. So don't let them go bad. Get them serviced. Thanks for watching the video. Hope you all have a great day.